today to... Oh, thank you, Jelena. We are honored today to represent you two of our speakers, Alessio Brutti and Martina Valente. Alessio is a tenured researcher at Fondazione Bruno Kessler, and he is our scientific coordinator of the ELOQUENCE. He leads the Speech Technology Lab at the for Augmented Intelligence, focusing on machine learning for digital audio and speech processing. Later on, you will hear more about Alessio, his work, his background, and his role in the Eloquence project. Our second speaker is Martina Valente. She is a speech technology engineering at Almawave company, and she's working in the voice engineering unit. She holds a degree in telecommunication engineering from the University of Trento and brings research experience in physiological and biological signal processing. Since 2020, she has specialized in the automatic speech recognition models across multiple languages, drawing inspiration from state-of-the-art to drive innovation in speech technology. We are excited to hear from both of them and their work, perspectives, contributions to this topic. And after their presentations and formal questions, we will have a session called Webcafé, where we'll have a couple of more questions from our side. And then the audience or you can ask whatever you want, whatever keeps you interested to stay with us till the end. So thank you once again, and let's begin. Alessio, the floor is yours.
Hi. Hello, everybody. Thank you very much for hosting me. Can you hear me? Yeah, okay, because I
Yes.
saw the screen freezing a little bit. Okay, so let's start from scratch. Thank you very much for the presentation and for hosting me here today. I would like to share some slides for my the screen. Okay, share. And full screen. So you should see the slide in full screen.
Yeah, we are seeing it.
Okay. Okay, thank you very much. So before I start, let me briefly introduce Fondazione Kessler and the role of Fondazione Kessler and of the Speech Technology Lab in Eloquence. So Fondazione Kessler is a research institute based in Trento, northern Italy, partially funded by the local government. And Fondazione Kessler is very wide, addressing several different areas of research, but in particular the scientific centers are focusing on the development of robust, trustworthy artificial intelligence that is available to all, and it is respect the ethics values and European values. FBK contributes to Eloquence, which the Speech Technology Lab, that as Nevena mentioned before, is the group that I coordinate, and our focus is on speech recognition and application of machine learning to speech recognition and speech processing in general. And I would say that in Eloquence, because we lead W4, which is the work package specifically addressing multilinguality and also bias and ethics related aspects, which is the focus of the webinar today. In particular, the VP is led by my colleague Marco Matassoni. And also, as Nevena mentioned previously, I am in Eloquence the scientific coordinator, so I help our coordinator Jordi in managing the project. Talking about multilinguality, I believe that recently there has been a considerable shift in the scientific community towards multilinguality. If you consider like 2-3 years ago, most of the works were based on English or Chinese, some of them. And this makes sense because, the need for reproducibility, comparison, large data set left not many alternatives to the use of these languages, which are very well resourced. But now recently, thanks to the release of new data sets, initiatives like Common Voice, Vox Populi, the availability of pre-trained models also in pre-trained in multilingual ways, considering multilingual data. This led to a growing interest in addressing multilinguality, in particular targeting low resource languages in the scientific community. And I think this is very important for us, in particular for Europe, because one of the characteristics of Europe is the cultural richness. This can be potentially an asset because we have diverse about technologies, in particular language technologies. This is a potential issue because the majority of the languages spoken by European countries or in the cultural groups in Europe are lower sourced if compared against English, Chinese, French, Spanish, and so on. And this has an impact, of course, on the performance and on the availability of language technology cities and companies. So here, for example, I would like to show this table, some numbers to support this statement. So this is the result of an activity that we did with our colleagues of the machine translation group in FBK, where we collected this was done a year ago, so maybe the numbers are slightly different now, but this is a collection of all the fully open science speech data available for the 24 European languages in hours. Okay. And you see that the total overall, we're talking about 500,000 hours of labeled data. The first column refers to data for which we have transcription available. The second column, data for which we don't have annotation, just audio. So I was saying the total amount of hours is pretty large, but if you look more carefully, the large majority of the annotated labels, the annotated data, is for English. Okay, it's 400,000 hours out of 500,000. And on the other hand, here I highlighted some languages. There are some cases where some languages for which the label data are the amount of label data is very, very small. Like here I highlighted Croatian, for example, but also Greek, Gaelic for Ireland, and then Maltese, Lithuanian, and so on. So there are this potential big gap, and this has actually an impact. So here in this slide, you can see the performance of an a current very popular automatic speech recognition engine, Whisper, provided by OpenAI. The performance in terms of word error rate on these languages that I identified before, considering 3 very popular open data sets. Okay, so you see that if you compare against English, which is of course one of the languages in which the general purpose open source tools available today are best performing, you see that the word error rates are considerably high, and sometimes making impractical the use of this tool. Okay, we'll look at, for example, Maltese or also Lithuanian and Estonian and so on. Okay, and this gap in performance is, of course, linked to the amount of data available in, for example, Common Voice and Flash. You can, now you don't have the time, but you can match the word error rate with the amount of data in the figure on the right. And so this is the issue for the availability of language technologies for all European citizens. Good institutions are aware of this at the European level, but also domestic level. So here, since we're talking about webinar related to eloquence, I will not go through the several national initiatives that different countries are launching. But if you consider for example, the European Commission in 2023, there was this call that was specifically focusing on advancing language technologies for all the European languages. And besides Eloquence, that is, of course, our project, two other projects were funded in the same direction. Okay, so there is awareness of this issue, and there are initiatives being taken in order to try to solve these problems at research, but also application level. So in particular, the Eloquence project that we are contributing to focus on multilingual and cross-cultural interaction and so on. So it's very specifically targeting the issues related to multilinguality. And as I mentioned before, our group, Speech Tech in particular in Eloquence, contributes to WP4, which is multilingual and bias-controlled language models, providing solutions for multilingual speech recognition and solutions which are specifically tailored to low-resourced and minority languages. So this is what we contribute on. So now, before I present some recent innovations that in our group we have contributed to within the Eloquence project, I would like also to introduce to discuss another important initiative, in my opinion, which is the Alliance for Language Technologies, which is a legal entity funded by several member states of the European Union. Now, this slide refers to a year ago, more or less. So the number of members is larger now. Many observers became partner of the LTEDIC. FBK, and in particular the Speech Technology Group, together with two other Italian institutions, has been mandated by the Italian government to represent Italy in the LTEDIC. So we are trying to make synergies between Eloquence and this other initiative, whose goal is, again, to preserve the linguistic diversity of Europe and respect European rules and values, ethical aspects, GDPR, privacy, and so on. So there are several initiatives at the European level that can be and can support the development of multilingual solutions, also preserving the cultural diversity of the different European countries and cultural groups. So now, going more on the, let's say, technical aspects, I would like to present a couple of activities, results, direction that we are exploring in Eloquence for low resource languages. Okay, the first one targets in particular the new speech LLM framework. Now, maybe the name is not yet very well established in the scientific community. There are different ways, but I think speech LLM is one of the most common. So it is new paradigm where you can use a pre-trained speech encoder, a pre-trained large language models connected with a very small network, neural network, a very small projector. So that you can leverage the knowledge and the functionalities of the speech, spoken language understanding, spoken question answering, and so on and so forth. Okay, so this is let's say, a rather established framework, although some research is still needed on the definition of the projector, the connector. Okay, the small block here that is normally trained. It is rather established, but most of the works are based on English, very common data sets in English, and still it's not clear how this this promising framework behave when we are dealing with low resource languages. So what we did, first of all, we wanted to try to understand many hours, actually, what is the amount of data that you need in order to train this small projector, okay? And then, there we observed that actually it is still, even if it seems something small, and most of the architecture is frozen, it is rather demanding. So we observed that you need like 150, 200 hours in order to be able to achieve a reasonable performance in terms of speech recognition, okay? We have started targeting this as task, automatic speech recognition, which is an amount of data, if you go back to the table presented before, is not available for many languages, at least in terms of open data. So one thing that we try to do, we try to leverage transfer learning, considering other some similarity in terms of is not new in speech recognition and speech processing in general, but we wanted to try to apply it to also this new paradigm. Okay, so what we did, we pre-trained the projector on another high resource language or multiple languages, and then fine-tuned on the target language. And here, I just report one of the results. This work has been accepted in interspeech and will be presented by our PhD student at the conference in Serafina at the conference in August. And so you see, for example, the performance for Galician, for which in Common Voice we have only 15 hours, so it's a very small amount. If we train from scratch on the Galician, or instead if we use a multilingual data set to train the projector and then we fine tune, we considerably improve the performance. So this is one of the things that we are doing, and we want to further investigate, eventually considering more languages for the pre-trained multilingual project. The other activities that I wanted to discuss today considers instead a more traditional speech recognition, an LLM, but a traditional encoder-decoder architecture, for example, using Whisper. And here the idea is to leverage the unlabeled audio data. Okay, so if you here on the bottom left, you see the same table that I presented at the very beginning, the first slide, and I highlight here the second column, the column with the unlabeled data, and there you see that amount of hours available for the languages is more uniform between the languages. Okay, we don't have English is not that predominant anymore. Okay. Still the largest one, but there are a lot of data also for other languages. So here, we'll try to data considering weak supervision. The idea is to have like an automatic in the base, yes, Whisper, automatically generate the label, filter, clean the labels in order to remove those automatically, in order to remove those that are not very that are not good enough. And to do this, we use and then use this automatically generated and clean the data to further fine-tune the model and eventually go on in an iterative way. And this is an approach that is actually giving promising results. You see here in the figure, for example, consider the Maltese. The gray column is the word error rate obtained provided by Whisper on Common Voice and Fleurs for Maltese, and then the other columns, orange, green, and blue, are different ways of using the weak supervision, and you see that we can considerably reduce the performance also for Lithuanian, for Slovenian a little bit less, but this is a promising approach. So these are. To conclude, I would like to mention another initiative that is not related to eloquence. This was year ago. It is an activity done again in collaboration with the Machine Translation Group and with the support of Cineca and FAIR project. And a year ago, we released this collection of open science compliant speech dataset for the European Union. The dataset is called for 400,000 hours of the unlabeled data reported in the table before. And this is a resource that is also being expanded by other institutions, other colleagues of the scientific community, and we believe this also is something that can be used and can be leveraged in eloquence to improve the performance in multilingual setting and low resource settings. Okay, so this brings me to the end of my my intervention, and I believe that multilinguality is a very very important feature that we are and a very important problem that we are targeting in Eloquence because it's in particular for Europe, because this will allow to make language technologies available to all the citizens, all the companies, without leaving countries of cultural groups behind. Thank you.
Thank you, Alessio, so much.
For questions,
I
of course,
have,
I'll be happy to answer.
I have 3 questions, just 3.
Request. Okay.
Just to highlight, could you literally highlight the recent advancements made by FBK regarding multilingual speech recognition? Just in short.
Sorry, can you repeat, because I was missing the I could not hear you.
Could you highlight recent advancements made by FBK, your institution, regarding multilingual speech recognition? So just in brief, short.
Yes. Okay. So the advancements are, I mean, those two that I mentioned. In particular, we are focusing on lower resource languages. So what we're trying to do is to lower resource languages. So, for example, the transfer learning method applied to speech LLM, or the use of data. We are also investigating let's say, the main advancements that we've been achieving so far.
Thank you. And how do you manage challenges around data scarcity in low-resourced European languages?
Okay, so well, first of all, let me say that there are a lot of initiatives to try to reduce this data scarcity at a national level. So I don't know if this will be a problem forever, but still the amount of data available for some countries will be very limited compared to English or Chinese. So what we are doing, let's say, we're working in 2 different directions. One is to try to find solutions that are less data eager, okay, so they require less data, and the other one, because maybe they start from already advanced point using versus data, and the other one is to try to explore unlabeled data, because those are available, but they're not easy to use, and it's not easy to then obtain very good performance with them.
And one more question, what role do multilingual AI system play in fostering digital inclusion?
Well, this is again what I mentioned at the very end. I think this is crucial in Europe because besides official languages of European countries, I mean, not only the European Union, in general of European countries, but also we have a lot of languages related to cultural groups, which are maybe not official, but are very, spoken in Europe. It's crucial that we are able to target multilinguality, because these groups, these countries are too small for the big players. Okay, so for them it's not very relevant to reduce the word rate. Maybe for I don't want to mention a country to avoid, but it's maybe not relevant to reduce them, and I think it's the research and the institution should take care of this, targeting multilinguality and making the language technologies available to all.
Thank you. Just check your network. It's a bit low in some moments.
Yes, I know.
Thank you, Alessio. Now we have a second speaker, and Martina. Martina, floor is yours.
Thank you very much. So let me share my screen. Okay. Can you see the slides?
Yes.
Okay, great. So again, hi all, and thanks for having me here. Thanks for the invitation. So today I'm here to represent Almawave. I would like to share some insights about real-world applications of multilingual speech AI in the industry. So first of all, let me just say a couple of words about Almawave. Almawave is actually an Italian company that is specialized in artificial intelligence, and Almawave delivers products and solutions for the digital transformation of companies and also the public administration. The company was founded in Italy, but has offices. Maybe. Okay. And also, Almawave clients are international. So the main specialization of Almawave is in technologies for natural language processing, but there are also many other solutions and offers regarding related to AI and also digital data. So I will briefly focus on the tech labs. So Almawave has 6 tech labs in Italy with more than 100 R&D engineers and 15 PhD students working in those. Almawave is involved into more than 12 research projects and also has collaborations with more than 10 academic partners. And here I highlighted the voice engineering lab in Trento, and this is where actually I work and where we develop solutions related to voice technologies. So the main areas of research of R&D are actually, again, as I was mentioning, natural language processing, but also other areas like machine learning, generative AI, conversational AI, speech technologies, data science, and others. And just to give you a brief overview about how the technology evolved over the years. So Almawave started as an NLP company. Then in 2010, the first suite of products was released. Then state-of-the-art technologies were added over the years. And in particular, in 2023, generative AI was added to the offer of Almawave. And in 2025, we had a release of Velvet. I want to spend a couple of words on Velvet as well. So Velvet is actually a family of foundational and instruct large language models. These models were trained in Italy on the Leonardo supercomputer. And they are currently available open source. They are released open source. You can find them on Hugging Face and Llama. And this family is made of 2 models at the moment. These are Velvet 14B and Velvet 2B. As you can see, both models are quite small in terms of number of parameters. So they are quite agile and also, let's say, sustainable. So the first model, Velvet 14B, is the best performing one and focuses on 6 languages, the main European languages, whereas Velvet 2B is more narrow, has a more narrow focus, and is just focused on 2 languages, which are Italian and English. And the pillars on which Velvet is based are mostly 3, which are aware, lightweight, and agile AI. And I would like to focus a little bit on the first pillar, because I think it's quite relevant for this workshop. In particular, Velvet was developed with the European and Italian cultural and regulatory context in mind. So Velvet is natively compliant with the EU regulations, such as the AI Act, the Data Act, and the GDPR. And in order to be compliant with this kind of regulations, a massive data processing and filtering was applied to the data that was collected. So just to give you some numbers, our colleagues did collect more or less 10 trillion tokens. But then after the filtering, only 4 trillion tokens were used to train the models. So a lot of data was discarded because it was not compliant. So in the end, this kind of model is classified as not at systemic risk under the AI Act. Okay, I will now switch to speech and voice services. And this is like more my area, so what I work with and what we do in the lab in Trento. So Almawave's voice technology division was born as a spin-off of Fondazione Bruno Kessler, that you might know. Research on speech recognition started there more than 30 years ago. And our technology includes components that cover very different aspects of the digital transformation of voice. So as you can see from the diagram here on the right, the technologies are very different. So it's not just automatic speech recognition, but there are also many other technologies related to speaker, to language, and so on. More or less, all of the components that you can see here on the slides are based on state-of-the-art neural network architectures. And for what concerns the ASR models, we have models available in more than 40 languages. And these models are also specialized for different application domains. And for what concerns the application domains, I would also like to give you a brief overview of some of the projects that the voice technologies was applied to along the years. So this kind of voice technologies were applied, for example, to get the transcriptions of court trials. This was done for both Italian, but also African countries. Then the technology was applied also for media subtitling. And this was done for projects related to regional broadcasting groups, but also national broadcasting groups, and also for international clients. Another interesting use case is the transcription of assemblies. So in this case, again, this was done for Italian municipalities, but also for Italian national assemblies. And last but not least, speech analytics. This is a solution that that was developed for different clients, mostly related to contact centers or customer service. So right now, I would like to have a look with you to a couple of applications that actually deal with multilinguality. So the first, let's say, project is a project regarding the automatic transcription and translation of the judiciary of Tanzania court trials. This was a project started in 2022, and actually was related to a bigger project in which the Tanzanian justice system was aimed to modernize the system by making it more efficient, but also faster and especially more transparent to those citizens who did not know the English language very well. Indeed, in Tanzania, the national language is Swahili, but the justice system mostly is, the justice trials are mostly done in English. So in this case, we did develop both transcription and the translation system. For what concerns the transcription system, I would like to give you some to look at some challenges that we had to deal with, and what was our solution. So challenges were, well, first of all, the bilingual speech, because we had two different languages. Then the technical language, so the presence of legal terminology, the presence of strongly accented English, and also very challenging acoustic conditions. Indeed, the recordings were full of reverberation, interference, and this kind of phenomena. And also, last but not least, the emotional speech, which is something that makes the recognition particularly difficult. And so the biggest challenge was to try to find a system that could balance all of the different aspects and could behave well in all of them. So the solution that we developed was actually a cascade system composed by a spoken language identification module to address multilinguality, the noiser module for the challenging acoustic condition, and also language-specific ASR modules for the two different languages. And all modules, especially the ASR engines and the spoken language identification modules, were domain adapted. So we performed domain adaptation both for the acoustic conditions that for the linguistic conditions and terminology. And also we added the possibility to use biasing lists. And this was very relevant for trial-specific terms or nouns or personal data that it was possible to add on the fly, basically. So this one was the first case study. I just would like to look at the second one, again, dealing with multilinguality. In this case, we worked with an international client who does broadcast monitoring. So basically getting the transcription and subtitling of different radio and TV channels. In this case, it was focused on Scandinavian broadcasting. Here the challenge is that on the same channel, different programs are actually broadcasted in different languages. And also within the same program, there are interviews or clips that are again in different languages. And there is no information about the language changes. And this might happen abruptly, but typically these are related to speaker changes. So they happen in sync. So the different speakers speak different languages. Also in this case, there is presence of L2 English. And when we approached this problem, we found out that the scenario is quite understudied in literature. So this is very different from, let's say, something that might seem similar, which is code switching, but this is a totally different use case. So what we did in this case was to propose a system that again combines different modules. And we found that applying a speaker-specific segment extractor at the beginning of our pipeline was very helpful to get the best results. Then we had spoken language identification module, and again, language-specific ASR recognizers. And in this case, again, the challenge was to find the system that best suited the specific domain, the specific use case. And for this, we also published a study in Interspeech last year. So if you want to have a look at more details, you can have a look at our paper. And the idea to build a cascade system like this is that it is easily scalable. So if we want to add more languages, this is very easy, and we don't need to retrain any module. And yeah. So the last topic that I would like to have a look at with you is some current/future development, which is the extension of Velvet, which is the large language model that I was telling to you about before, to multimodality. So in particular, our group will be working on extending Velvet to perform speech and audio tasks. And later on, it will be extended to images and videos as well. And the idea is to have a monolithic model composed by an audio front end and again, the LLM, similar to what Alessio was showing to us before. And in the beginning, we will focus on the main European languages. but then it will be extended to other languages as well. And the idea is to have one model that performs many tasks. In the beginning, focusing on automatic speech recognition, speech translation, and vocal interaction, and then extend it to other tasks. And this is possible because we will try to exploit the multitask capabilities of LLMs. Again, the model will be open data, open parameters, and compliant to AI Act. And that's it. So thank you very much.
Thank you, Martina. I have, I think, one question, because from the prepared one, you have already answered for the future developments, and you shared with us case studies or projects that you're working on currently. So this one question: how does Almawave approach trustworthiness in the multilingual AI solution?
Yeah, so as I was showing you before, I think that trustworthiness is one of the main themes that belong to, this kind of EU regulations that are being developed and released along these years. So I think that the biggest efforts are indeed in the development of this kind of large language models. So both the text-only ones and also the extension to multimodal. So all the efforts there are actually to meet these kind of requirements, including trustworthiness, but also like bias limitation and so on. And I think that most of the efforts are actually done, again, on the data. So there is a lot of work in trying to process the data, to understand the sources, to verify. Because even if the data is open source, this doesn't mean that it meets all the, all the requirements that this kind of EU regulations are trying to enforce. So there is a lot of work to be done, and of course we try to do our best with the with the tools that we have at our disposal. But I guess that a lot of work is being done in the scientific community as well to try to continue improving this kind of tools.
Thank you for replying. We are now opening the Q&A session, or Webcafé session. I have prepared 3 questions for the speakers, and if everyone else wants to ask something, you can do it basically in a few moments. So prepare your questions. For the speakers, for the Martina and Alessio, what motivated you personally to work in the multilingual AI space? So whoever wants to reply first.
Ladies first.
Thank you, Alessio.
Okay, no, I said ladies first, but okay. No, so well, personally, okay. I would say there are two reasons. The first one that I also briefly mentioned before, I think that there is this issue related to lower source. There's this gap in the current technology for lower source communities that are not big enough for the big players, and I think it is a duty of the research funded by taxpayer money to target, to tackle these issues. And this is one. The other one, it's also a clear direction for research where there is, it's an area that we can actually target without being in competition with the big players, which an unlimited amount of resources available. I'm also referring to Almawave.
Mm-hmm.
And so that's are the two motivations.
Thank you, Alessio. And Martina?
Yeah. So, well, I personally have like a very personal reason that I really like to study and explore different languages. So I think that working in this field is very interesting, just for my personal interests, and this is something very, personal. And the other thing that I think motivates the work is also to develop systems that can actually help people. So, as I was mentioning before, for example, for the Judiciary of Tanzania project, in that case, the whole project was made with also with the idea of making, this the judiciary system more transparent to people. And when you know that you are working with this objective, I think this is, something that motivates you more than maybe just targeting a 1% with error rate reduction.
Yeah. Thank you. Thank you. Next question. Can multilingual speech AI truly overcome cultural barriers? And what's your take?
Well, I think, okay, again, I think that there are, I mean, I am quite optimistic in this regard. I think that there are a lot of initiatives. We spoke about Europe, but the same applies to other regions of the world. And there is awareness. So I believe that also thanks to the outcome of Eloquence and the other initiatives in this direction, there will be solutions soon that will provide fully multilingual AI.
Thank you. Martina, what do you think?
Yeah, I also think that this kind of multilingual efforts towards multilingual AI are very useful. And of course, they can, they come as a facilitator they help people communicate better. So I think this system, maybe they will not actually, break the cultural barriers, but at least help, reduce them. Because again, the systems are improving at a very fast pace, but there is, I think that's something that we tend to maybe underestimate is the fact that truly understanding the culture behind a language is not that easy. So something that we have noticed is like in benchmarks, sometimes I'm talking about LLM benchmarks, for example. If there is an Italian benchmark, this is just a translation of the English benchmark. And there are things that are lost in translation. So sometimes, especially when maybe the translation is automatic or things like that, there are some, maybe some aspects of some cultural aspects, some aspects related to, some specifics of the language that are actually lost in translation. So I think that some efforts that are, let's say, advisable are to try to, consider languages as a whole, and of course, creating more and more data that contains, that is able to represent not only the language, but also the culture. I know that this is very difficult, especially for low-resource languages, but if you have 10 hours of data, it's already something, but this is something that I advise.
Thank you. And the last question from my side. What are the ethical concerns that keeps you up tonight when developing multilingual AI? So just count one that comes to your mind now.
Yeah, it doesn't keep me up tonight, however, but
We're
one
just
issue.
saying it like that.
Yes. Well, it's also what Martina mentioned about the data. Of course, the risk is that you try to collect whatever is available in order to increase the amount of data. And of course, there are limitations on what you can do with the data. You cannot just scrape the web and collect what you need. And on this, however, we are very, our group, we are very, very strict, and we try to do our best to be sure to use data that can be used for training models for this purpose. In particular, we have an initiative again with the machine translation group. We are training. We trained a foundation model, speech foundation model for Italian and English, using only open science data, so which are fully open and can be reused by everybody.
Thank you, Alessio. Martina?
I will mention again data processing and filtering. So it's always about data, and in this case, something that concerns me a little bit, even though I can't sleep well at night. It's the fact that even though you apply many pipelines to process and clean the data, you can never be sure that every bias is removed, every potentially hateful speech is removed, and these kind of things. Especially when you are working with massive amount of data, because let's say 10 years ago, the data, even though you might need a lot of data to build models, it was still manageable, let's say. Right now, it's very difficult to have control on all the data that you're using. So the automatic pipelines, again, can do up to a certain point. And then, maybe some guardrails have to be applied on the trained model, because you will always find some, biases or inappropriate, let's say, behaviors. So, yeah, that's something that it concerns me.
Thank you. Thank you to both of you. And thank you for having such a great presentations. I'm finished with the questions. And I'm asking the audience if someone has something to add or to ask. Okay, Lorenzo.
Yep, hi all. Yeah, thank you, Alessio, and thank you, Martina, for the presentations. Yeah, I would have a question for you, Martina, regarding the system that you developed for the Scandinavian project. So in that case, you mentioned that you preferred going for several ISR models in parallel instead of like one for each language. What's the reasoning behind, instead of just choosing a multilingual model? Is it because they perform better on single languages or something else?
Yeah, I think the reasons were a couple of reasons. So yeah, we found that the performance of single language models, as you mentioned, were better in this case, and the other reason was scalability. So in the beginning, we released a system in which we had, I think, 3 or 4 languages. But then, the requirements of the customers might change over time. So we also had to favor some solution that could be, easily extended to another language without retraining the whole system, because we could not just take some general purpose ESR model, but we had to adapt the engines to the specific domain, the specific terminology, and these kind of things to have competitive performance. So the idea there was that if the client would ask for another language, we could just add this kind of piece to our system without too much effort.
Yeah, I see. Okay, thank you.
Thank you very much.
Thank you. Someone else?
Yeah, if I might say something, it's Jordi.
Yeah, Jordi, go ahead.
Would like to first of all thanks to the speakers for really interesting presentations, and thank you for joining the webinar webinar from organized from Innocence team, and thanks to Nevena. It's also related to the question that Lorenzo was raising, because it's anti-intuitive, right? That for example, from my experience, I usually speak two languages, right? I will say that I master both of them, that is Spanish and Catalan, right? And it doesn't happen to me in English because I'm not mastering English, right? But for example, when I'm talking in Spanish and also switching to Catalan, in fact, I do it without thinking, right? So to me, when I'm in a conversation, maybe could be even a conversation that people that only has one language doesn't understand that this could be possible that happens. That is having a conversation in two languages in both senses. I mean, one speaker is speaking in Spanish, the other speaking in Catalan. Sometimes we switch the languages, and we don't realize we're talking two languages, in fact. And the question here, or the point here, is that maybe, I don't know what you think, and this is a question for both of you, that maybe when you have not enough data for one language, probably it's also a good option to go for this switching approach, right? And you have specialized ASR systems that are mastering one of the languages. And when you have enough data for all the languages, maybe it's a better option. Besides the scalability, it's a better option to have just one language that is able to be trained in enough resources. I don't know what your opinion about, or I don't know if you've understood the question because I didn't explain myself pretty well, but you think it's a problem of resources having this approach?
Yeah, so I think I did not understand very well the approach that you propose, sorry.
No, I mean, my question is that, for example, having my experience, right? I'm just trying to make a metaphor, right? With the point that I'm not able to distinguish if I speak in Spanish or in Catalan, because I master both of them.
Yeah.
But for example, when I speaking in English, I need to think first that I'm going to go to English, like your system. Your system is first detecting the language and then switching to one specialized model, right?
Yeah.
And my question is, maybe this is due to there is not enough data for mastering both languages at the same time, or?
Oh yeah, I see your point. So
Or it's just a matter of scalability, right?
Yeah, something different. So something else that we were addressing while working on this project was actually the readability and also the robustness. So sometimes we could see that if we had systems that maybe understand, let's say, both languages, and there are language changes, sometimes these systems were less robust. So they could insert parts of one language into another. And so the readability was very, very much, decreased, even though maybe the word error rate in the end was not very different or was comparable to the cascade system. The readability was very different. So we found that for our specific use case, this was the cascade system was actually working better and was more robust, even in terms of readability. But this was specific, especially because we had a very good system that was able to detect the speaker-specific segments. So basically a speaker diarization system, similar to that. And was working very well for our application. But for example, in the example that you mentioned, if you had a speaker that keeps changing language,
doesn't work.
Then of course it doesn't work. So it depends very much on the.
So you need both, right? You need the speaker tone detection plus the language identification, right, at the same time.
Yeah, exactly.
Thanks. And maybe this is a question also for both, because you were mentioning the special at the boat. I mean, work that is needed to clean and data curation, right? And for example, in the case of Martina, you were mentioned, for example, this removing of personal information, right? That is done, for example, for LLM training, right? In Valente. And also Alessio was mentioning in his presentation the data cleaning, right? That was done. So I don't know if these kind of systems can be applied in speech, because, for example, in the cases that you mentioned, Martina, I mean, there are a lot of, for example, you were mentioning multilingual code transcription, right, and different legislative proceedings. And there are a lot of information, personal information in those documents, probably spoken documents, right? And it's going to be, I think, probably super hard to remove this information from a speech directly. I don't know if you transcribe and then remove it, or how it usually works, or you work in the speech space directly. I don't know.
Maybe I can answer first. So no, usually the data processing is based on the transcript.
Mm-hmm.
So we start from the transcript and then we do some anonymization for these kind of procedures based on the transcripts and on the alignments that we get from between audio and text.
Mm-hmm.
So yeah, this kind of work is, or sometimes if there are some sentences that get discarded, for example, if they contain personal information, and we keep only the data that does not contain.
So this PAE works in a text space, right? So this privacy association editing tool.
Yeah, exactly.
Okay. Thank you. Just curious. I don't know if it is possible to make it in the speech, but I was curious about it. And just my last question, and probably this is for Alessio, because I mean the result you presented about the Galician, it was kind of shocking, right? Because I mean it's something like you can title something like "Speak me in Italian because I want to learn Galician," right? Because you were fine-tuning a system using, if I was right, 200 hours of common voice data, right? And then you obtain better results, right? Or even a combination of multilingual data, and you obtain much better results than just training with 20 or 10 hours of Galician, right? So, and then the bottom up will be that thing, right? So speak me another language because I want to learn my own language, right? So,
Yeah.
and the question just to finish, do you think there is an optimal combination of languages for training?
Yeah, well, I mean, I think this is related to your comment before when you were discussing about the multilingual model or individual model. I think it depends also on the language similarity at the phonetic level. Now, don't get me wrong, Jordi, but maybe Catalan and Spanish are somehow similar, okay? So they're different, but they have some similarities at the phonetical level. And so this is what we did for Galician. We tried with the Spanish and Italian. And then, I mean, since we don't have a way at the moment established to measure the similarity, we did something multilingual where there is a little bit of everything. But for sure, probably there is an optimal combination of languages that you can use to train, and then you fine tune on the target language. And now we're trying to work at the phonetic level, okay, is where you don't have the static information, and there where we can better leverage the similarity between the languages. So a is a in several languages. No, you can leverage this, or o. There are some phonemes are very common, no? And so we're trying to work in that domain, in that space.
So yeah, so the expectation is that the families that belong, or languages that belong to same families, or have a shared acoustic space, probably they will boost much more, no, themselves. I mean, so for example, tonal languages like Chinese or Vietnamese, probably they don't help too much to Roman languages, for example, right? But it's just it need to be tested.
Yes.
Cool. Thanks a lot. I'm not gonna take more time with you. Thank you for your patience and answering my questions.
Thank you very much for your questions.
Does anyone else have some questions? Okay, no one is raising a hand. Thank you once again. And thank you, Lorenzo, and also thank you, Jordi, for questions. We will have more webinars in the Eloquence, so I'm inviting you to join, to follow us on the social media so you can follow upcoming events. And for now, take a rest and finish your tasks for today, and that's all. Thank you once again.
Thank you.
Bye.
Thank you. Bye.
Bye now.
Bye bye.
Thank you.
Thanks.